Okay, great. Yeah, so as you mentioned, I'm Benjamin Abt. I'm a data scientist at PartnerRe in the Life and Health team. Just bouncing on Stella's presentation, part of my job is also to promote R within our company and to convert people from, well, in our company, mostly from Excel and VBA to R. But we have similar topics. I didn't convert yet hundreds of people, but we're getting there slowly. Yeah, so just to react on it for us, the main point on that was obviously to provide trainings, but I think the key element is also to demonstrate the capabilities. So having more and more people programming in R and developing tools in R shows to the skeptics that yeah, they can do with that much more than they can do with Excel. So it's a process well on its way. So to come back to my talk, yeah, so I worked for PartnerRe. Sina mentioned that we sponsored the event, and kudos to the organizers to have moved the SatRday to an online thing. It's not easy. We do this kind of stuff at PartnerRe too, and I know it's pretty hard, and especially on such short notice. Sorry. So yeah, PartnerRe is a reinsurance. It's a risk insights company, which means that we use data to understand risk in the reinsurance business. We are present all over the globe, partnering with insurances to help them protect people, cars, houses, agriculture, aviation, you name it, many different type of businesses. Today, I will talk to you about how we use R in production at PartnerRe, focusing on our infrastructure and what works and doesn't work for us. So yes, it's a talk about tools, processes, and so on. And for data scientists, it might not be the funniest topic. Even for myself, I mean, as a data scientist, I basically want an infrastructure that works. And when I go to conferences, I'm mostly interested in, let's say, RStudio, Joe Chang's latest topic than the newest thing about Azure or AWS. But as soon as you enter the corporate world, and as soon as you leave the premises of your own laptop, infrastructure is actually key to deliver data science, and it's also key to make more complex and fancy stuff. So when we talk about R in production at PartnerRe, we mainly provide our clients or our internal colleagues with three main outputs. We do automated reports used by decision makers. So that's a really typical task where we have a data source and we want to transform that into insights for the decision makers. We have a company with history, so you can imagine that we have multiple types of data sources going back a long time. We have newer stuff coming on a recurring basis. Then we also build tools for reinsurance pricing and also actually reinsurance reserving. So that's a main topic in a reinsurance company, because you will take some risk away from insurers, and you want to define the best possible price for it, the price you'll get paid for taking those risks. And obviously we are also in a competitive market, so we have to be spot on, but also yeah, well, gain money from it, not lose any. Finally, we also train machine learning models. An example is something we've built for our underwriters. So those are the people that actually sign on the risk that they select. They select the risks, and we developed a machine learning algorithm to help them take decisions on health cases. Some examples of packages we use, I've put here the hex stickers of some of those. You might be familiar with many of those packages. So production environment, how do we define it at PartnerRe? We put here 6 main aspects of it. High reproducibility, that's a topic that is common with scientific studies. For example, we want to be able to know where a number comes from. So we cannot just do a one-off production and that's it. We need to be able to go back in the past and be able to reproduce that number or that analysis. The infrastructure, the production infrastructure needs to be highly available. That means if we have a problem, for example, with a server that goes down, we need to be able to bring it back in a matter of minutes, and running services need to recover to running state again very quickly too. Another point that is key is that it has to be usable for both technical and non-technical users. By this, I mean that we have at PartnerRe a growing base of rather technical users, both in R but also in the other tools of our infrastructure. But we have also internal end clients that might be less advanced. And this infrastructure is also meant for them, obviously, and it has to be simple enough so that they could get out valuable information. It should be shareable. That goes a bit with the previous point, but also that everything must be in either a container or a package so that it can be easily shared with others, both internally or externally, if needed. It should be finally secure and auditable. While security is a common problem for many, auditability is rather on the corporate side of things. So we work together with our security team to ensure that our code is secure and also auditable for end-user purposes, for example. So yeah, since we have multiple teams spread across the organization, developing tools that end up in production, we also developed guidelines on code development and deployment. And also those are rather soft guidelines. For a tool to end up in this production type of condition, it should follow these guidelines as much as possible. So before we go into more details on our infrastructure, I want to give you an overview of the process that we use to develop a tool and take it to production. For each step of the process, we've included here the components of the infrastructure used in each. So the first step is obviously to gather the business requirements, the goal of the project, which problems it aims to solve, who is the target user, and so on. Then we put together a plan, a design on how we intend to approach the problem and what the solution could look like. We could be deciding it's a package in the end, it's a shiny app, it's just a dashboard, just a GitLab page, for example. The documentation created in those first 2 steps, we store it in GitLab so that this way everything that defines a project is stored in a single place and can be easily found. At this point, we're ready to start developing, testing, and finally deploying our solution. On the next slide, we'll go into more details about each of the technologies used on these three stages. So that's a view of what we currently use. We have a few other tools in place, but that are not yet in production status. So for development, we share a single RStudio server, which is connected to our shared drive and databases, both on premises, by that I mean within PartnerRe walls, and on the cloud. We use GitLab for source code management and version control, and this is a critical component of our infrastructure as it is now. We store here, as I mentioned before, all information about the project, for example. Then we also use GitLab's CI/CD pipeline to test our packages and ensure that all code stored on GitLab is fully functional. So if you're familiar, for example, with the test.dat package, we build, as we all should, we build tests on the package, and those will be actually rerun, those tests, each time we commit new pieces of code to GitLab. And it will be done automatically. To deploy our tools, for instance, Shiny apps, we bundle them as our packages, and then we install them in Docker images. For those who don't know what Docker images is, they are standalone executable packages that include everything in the, for the environment to run a piece of software. And finally, we use a Shiny proxy server, which is an open source platform to deploy Shiny apps to run those Docker images. So every time a user runs an application, a Docker container spins up and runs the different analysis it contains. The infrastructure solution needs to be able to address the challenges around the production environment. And I've just shown now the current status of the infrastructure, but we are facing challenges that made us move, to new solutions. So we are now going through the challenges that we face as a company at the moment. As I was mentioning, we are converting more and more people to R. Over the last few years, that means that we get more and more users for our infrastructure. The number increased, but also the complexity of the work we do too. And having a single server has been challenging over the last few months or year. And that's been challenging. So the scalability has been challenging because the resources are located on premises, and they are not really able to grow according to our needs and tasks. Also, resource consumption is harder to control, and we end up with users taking a lot of resources and others that require less resources not being able to access all the infrastructure. Then, as most companies around the world, and especially also in Europe, we are facing strict data restrictions. As a reinsurance company, we get a lot of sensitive data and information. GDPR applies to us, but we have also, in other countries where we work, local rules like in Switzerland and Canada, for example. Then complexity. Well, our projects tend to be more and more complex, but also the number of internal developed packages increase, dependencies become harder to manage. Finally, automation. Yeah, we basically want to automate as much as possible across the pipeline. So now I've shown the current infrastructure, the challenges that we are facing, and we'll now show what's our future solution. And we are moving to a hybrid cloud solution. This means that we will be able to address most of the issues by moving parts of the infrastructure that we have in-house and premises to the cloud, while we still will be leveraging the current resources we have already built and configured, for example, our databases. This will allow for a sort of gradual transition as resources can be limited in the beginning. The communication between components and on premises and on the cloud is done through VPN tunnels. So that's taking the security issues. So scalability, how does this help with scalability? We'll have the development done both on premises and on the cloud. Each developer will have their own virtual machine running on instance of RStudio. This way, they can spin up resources and scale it up or down as needed without interrupting resources for others. For instance, we have catastrophe modelers at PartnerRe that often require a lot of memory for their computation and have sometimes huge data. And with this setup, they will be able to scale up resources easily. However, we will keep still an RStudio server on premises to facilitate adjustment for new users. Then about data restrictions, the fact that a virtual machine is assigned to each user, we can define rules to access data for each of them. For instance, a user in Canada will be able, well, we'll make it that that user is able to access data in Canada, but the French or the Swiss user won't. And therefore, the requirements of GDPR and others will be fulfilled. Sorry. Now to complexity. To better manage internal package dependency, we created an internal package repository for our internal developed packages. So that's what we have here on this preprint thing. Let's use the cool Zoom stuff. And that's basically like CRAN, but we host it on premises. And it makes it much easier to install and to follow, to track which version of the packages we have there, which one we install and use in our analysis. Finally, for automation, we use already GitLab CI/CD pipeline, and we automate this way our deployment process. We will have Kubernetes in place for container orchestration and automated application development. And the goal is to have a fully automated deployment process both on testing and production environment. So that's what the process would look like. Each developer connects to either, let me clear my drawings here, to either the RStudio server on premises or its own instance on the cloud. In both cases, they would do so via VPN tunnels to ensure that communications are secure. All instances of RStudio have access to our shared drives, databases, and our internal package repository. For version control, we will continue to use GitLab. However, we might switch at some point to a better suited solution in the future. We intend to keep using CI/CD pipelines and expand its application. Finally, having a fully automated deployment process starts with the CI/CD pipeline and will allow us to deploy our tools both on testing and production environments easily and consistently. So to summarize, this new hybrid cloud solution approach, it will allow us to scale while maintain the familiarity we have with the current environment, meaning current users will still be familiar with the infrastructure, but at the same time we are moving to a better solution for everyone. Moving to the cloud also buys us flexibility as environments are easier to reshape and grow and adapt to the needs. Not starting as a cloud native also puts less strain on technical resources. So I wanted to go from this to an application. So I'm going to show something very simple, actually, that uses most of the tools we currently have in place. So it's something very, very simple. And the content of it is actually not the point of showing it. I have to go back to this mode. Okay. So I've changed the title, but I guess you all know what it's about. It's just I didn't want to mention it once more. I guess we are all fed up with the topic, but still it was an example I had available. I hope you all see the RMD file, and well, not the RMD, but the output of the RMD file on your screens. If not, please write me on Slack or on the chat. Okay, nothing. So why I'm showing this is not really for the contents. I'm showing it because it uses most of the infrastructure I've been talking about. Here we see, let me take this annotate thing again. We see that we have RMD template that is corporate adapted for PartnerRe. We have developed a package just for that, where we have this template, but also one for LaTeX, one for well, LaTeX PDF, one for Word, one for slides. We have a package around PartnerRe colors, a package around PartnerRe ggplot themes, things like that. And those typically are hosted on this pre-CRAN type of repository. Yeah, so here again, the content is not super important. It's more about showing what we do. So here I just harvest some data from Wikipedia, do this plot that is PartnerRe branded. I extract automatically some plots from a report, a PDF report, and I store some of those plots somewhere, because on the internet the sources disappear at some point, and it's all hosted on our GitLab server through a GitLab page. And it's actually a cron job, so every day it will be updated with the latest data. If I want to put it back to the real topic, actually, I can just change in my RStudio the title. I committed, well, I save my file. I commit it to GitLab. Back to a real topic. I commit that, I push it to GitLab. Sorry for going quick, but I see my time is gently running out. I push it to the GitLab server. Everything is up to date. I go to GitLab. I look at my pipelines. At the moment it's pending. Probably another job is going. Yeah, in a few minutes, it will update the whole analysis and republish this page with the new title. At the same time, it will also do the rest of the analysis, harvesting the websites, and publish the latest analysis. So that's a really typical thing we do with more interesting topics and more complex ones, but that's a good example. So if we go back to our slides now, yeah, here they are. So what do we use here? We used, well, I'm the developer. I've been working for the last 2 weeks from home, so VPN tunnel definitely has been used. Pre-CRAN for the packages that I mentioned, the template and so on, the colors. Data storage to store, at each run of the analysis, it will store the plots. RStudio, as you could see, is my base place to define the analysis. GitLab stores the code, but also GitLab CI/CD will run the Docker image and run the analysis and send the page to GitLab. Here I've put the Shiny proxy server just because the GitLab CI/CD runner is actually hosted on Shiny proxy server because it has the capacity to run Docker images. So yeah, we have an infrastructure that can do very complex stuff, but it's really cool actually to see that it can do very simple things in a very short amount of time. So just to finish up, let me clear this again. Here are a few resources about DevOps that are really useful to us to develop our infrastructure. I've been mentioning publishing to pages. I have also helped 2 days ago, tried to help actually a colleague to deploy something similar, but using H2O, and ended up with some issues. So we still have bits and pieces that are missing, and that brings me to my last point, which are actually job offers. At PartnerRe, we are currently looking for an analytics platform lead in Zurich to join our tools and technology team in the life and health department, so in the same department I am, and to take over parts of this move to the future solution. And then for people more in the data science field and that are willing to move to the US, we are looking for a data scientist in North America. So as you know, at the moment, you can't go there, but hopefully in a few months, if you're interested, you'll be able to join PartnerRe. Yeah, on this, I'm open for questions.
Yes, okay, Benjamin. So maybe you can see the question on the Q&A.
Yep, I see a few.
Yes, so, and we have also 2 other questions from the speakers who can't access your Q&A. So maybe we'll try to respond to everyone.
Yeah, I'll try. So the first one I see is, did you try RStudio Connect or other equivalent all-in-one solutions? I think we have tried RStudio Connect. Yeah, why we didn't move towards that, I think it's mostly driven by some of previous choices, but also some of our current challenges. And yeah, the move to the hybrid cloud, yeah, seems actually better suited to us. Yeah, I'm not able to go into too much detail on this. First, because I'm not too much into this development. But yeah, I hope that answers parts of it. Okay. What all cloud provider you have experience with? Which one do you prefer? Oh no, it's moved.
No, it's on the top because the other one was
upvoted.
Yeah, it was solved. So yeah, no, you have the second. Yeah. So what cloud provider? Which one do you prefer? Is there a particular cloud provider that provide better infrastructure for our workflows?
I think, and again, it's not directly with my team that it tries at the moment. It will be more with the person also joining us, hopefully soon. But I think at the moment, Azure is our preferred one. I hope I'm not saying anything wrong here, but last time we discussed it, I think that was the preferred choice.
Okay, so the next one was, hello, why at your company you need to convert to R?
Why do we need to do it? Well, it can seem like a trend that data science is taking over in many companies and in the insurance business too. And it's I think a valid feeling, but once you work with R in the field, and I've been an actuary before, and I still am an actuary. I moved to data science to some extent, but I'm still an actuary, and definitely the actual world has been stagnating somewhat. I mean, there's still research being done and so on, but the tools also sometimes limit the work we do as actuaries. So it's not that we need to do it. Well, to some extent we do because there is a pressure of the market, but on top of that, I think we are really able to provide both our clients and internal colleagues with much more than we used to just using Excel or VBA.
And so the next one is data scientist is a term thrown around a lot today, and company to company have different definitions for this position. So how can I, as a bachelor student and future data scientist sell myself to this business in the correct way?
That's a tough one. I mean, it's clearly a young field and a young termination. It could evolve in the next few years in different ways. In our industry, in the reinsurance industry, I would say I have, for example, a hybrid profile. Some of my colleagues are really full-on data scientists. So it depends a bit on your profile. If you see yourself as a pure data scientist, then definitely you should be able to bring some hardcore machine learning, deep learning, even SQL type of skills. If you're more hybrid, I think you should aim at the industry you are trained in or the topic. For example, actuary, insurance, but I don't know, biology, maybe go to biotech, and then bring this kind of both hats type of profile, showing that you can both know the market you're working in and also bring some data science skills.
Yeah, okay. So thank you for your answer. So we have to move to the next speaker. So there was more question, but if people want to ask more questions, they can join you at the break in your... Okay, so thank you, Benjamin.
Thank you very much.
You're welcome. So